this a quick video to try to help you if you found it. Try to help you with the Chapter 8 test. The first three, I'm not going to mess with the first three. You're just telling whether they're independent or dependent. We'll start with number 4. And I'm just going to run through some stuff real quick. It says a real estate agency says that the average home sales price in Dayton, Ohio is greater than sales price in Cincinnati, Ohio. So for part A with the HO and the HA, they're saying Dayton is greater than Cincinnati. Well, then that's going to have to be your HA when you put it in there. And your HO would be the opposite symbol, which is less than or equal to. And that would tell you that it's going to be right-tailed. You need that for on down in the problem. And don't forget to tell which one is your claim when you do your HO and your HA. Part B. For Part B, you have to do 1 minus the alpha to see what you're going to look up on the chart, and you're going to look it up on the normal chart, the normal one or the Z chart. So you do 1 minus alpha, and then you look up that number, and that's going to tell you your critical value. And don't forget that we set up here it's right-tailed, so that means it's this part. So you should be a positive number there for your critical value, your Z sub 0. Letter C. On letter C, the formula you use on letter C is Z equals X bar 1 minus X bar 2 minus the mu's subtracted from each other, which is always 0, over the square root of S1, which is the first standard deviation squared, divided by N1 plus S2 squared divided by N2. So that's the formula that you use on that part to find your Z score. Letter D, once you find this Z score, you just check to see where it falls over here in the graph, and that'll tell you whether to reject or fail to reject or fail. And letter E, don't forget with letter E, on all the way through the test, it's going to start off with something like with, some percent, level of significance, there is, and then we use the chart. Decide whether it's the, remember you got to look back up letter A and decide if your claim was your HO or your HA, and use that chart and make sure you connect it to the problem. So in this one, it's going to say there is not enough, or there is enough evidence, or whichever one it says, to support the claim that the price or the house prices in Dayton are greater than the house prices in Cincinnati. So hopefully that'll help you with number 4. Key thing here that I'm showing you is that's the formula you got to use to find your Z sub 0. Number 5. You look at number 5, they just give you the X bars and the standard deviations. So on this one, you don't have to find those. On number 6, you might have to find them. or on some of them you may have to find that stuff. I don't think on number 6 you do either. So part A is just your HO and your HA again. And it says it actually tells you that the claim is mu1 equals mu2. So that's going to go as your HO, and that's your claim. And then fill in your HA here, which would be mu1 does not equal mu2. Part B says find the critical values. To do that, we're going to use the T-chart. And to use the T-chart, we need to know the alpha, which is 0.10 for this problem. And we need to know that the variances are equal. And the reason we need to know that the variances are equal is so we can find the DF. If the variances are equal, then the DF is N1 plus N2 minus 2. And they tell you what N1 is, they tell you what N2 is. Subtract 2, then you should be able to find the DF there. Then use that and your DF on the T-chart to find your critical value. Something we should have done up here in number 1. Since it's got that symbol, we should know it's two-tailed. Well, when you go to draw your little graph, then you're going to have this tail here, and you're going to have the two critical values. Remember, you look it up on the T-chart, and one of them's going, you're just going to make this one a negative, make that one a positive. Draw it in there. C says find the standardized test statistic. The formula that you need on this one is x bar 1 minus x bar 2. Again, minus the mu's, which is just going to be 0, over, since the variances were not equal, we got to use this big long formula, which is N1 minus 1, that's hard to read, I know, times S1 squared plus N2 minus 1 times S2 squared, all that over N1 plus N2 minus 2 times this is still all on bottom, square root of 1 over N1 plus 1 over N2. So since the variances weren't equal, use all of that. Use all of that to find your T-score. Once you find your T-score, once you know what it is, you're going to see where it falls on this graph right here. And that's going to tell you part D, which is either to reject or fail to reject. The HO. Number 6. In low speed crash test, the mean bumper repair cost of 6 randomly selected mini cars is $892 with a standard deviation of 205. What you might want to do on this again is write down each thing, X1, N1, and S1. So in this case, X bar 1 is 892, N1 there was 6 cars, and then S1 is 205. That's for the mini cars. And similar test, 16 random mid-sized cars. So we're gonna have X bar 2, N2, and S2. Write all those down. Those are the numbers you're gonna need for each of the formulas. Mid-size cars, mean bumper cost was $989. There was 16 of them, and the standard deviation was $324. And our alpha is a 0.01, 1%. Can you conclude that the mean bumper repair cost is the same? So that's going to help us with part A. The claim is that they're the same, so our HO is going to be mu1 equals mu2. That's the claim. Then you can fill in the HA there. It's just, instead of equal to, it'd be not equal to. That tells us that it's two-tailed. So for part B, we got to find the critical values. Again, we're going to use the T-chart because we're dealing with small sample sizes. Our alpha is 0.01. They told us that the variances are not equal this time. So there's different formulas when the variances are equal, like on number 5, and not equal on number 6. Our DF then, all we do is take the smallest in, and we do that minus 1, and that's going to give us our DF. Then we use those two things to find our critical values. We're going to draw a little chart here to find our T0. It's two-tailed, so it's going to look like this. Use your T-chart. Remember, you're going to find the positive answer on the T-chart. Well, then you just make the other one the negative answer and put it there. Letter C. Find the standardized test statistic. A little shorter formula on this one when the variances are not equal. X bar 1 minus X bar 2 minus the mu's, which again we're going to assume is 0, over standard deviation 1 squared divided by N1 plus standard deviation 2 squared divided by N2. Once you find that T value, see where it falls on the chart, and that's going to let you decide whether to reject or fail to reject. For part D, and then part E, remember, is where you got to explain it. So you're going to say something like, with a 1% level significance, there is or there is not enough evidence to do whatever for the claim that the bumper repair for mini cars and mid-size cars is equal to each other. Number 7. Number 7, they just give us the numbers there, and we just got to do each thing. So they actually tell you that the claim is mu D is greater than or equal to 0. So that's going to be your HO. Mu D is greater than or equal to 0. Then our HA is going to be mu D is less than 0. This is the claim right here. Part B says find the critical values. Again, we're dealing with small sample sizes because they tell us N is 17. Oh, up here we should have said, since it's that's a left tail. So we need to know that that was a left tail. It's going to be a left-tailed graph. We use our alpha, which is 0.05, and our DF. We just do 17 minus 1. That's going to give you your DF. Use your N minus 1. You use the T-chart. So look up on the T-chart, that's gonna tell you your critical value. It's left-tailed, so it's over here. And remember, when you look it up, it's gonna end up being a negative, so your value there is gonna be a negative. Part C, to find our test statistic, we do D bar minus mu D over standard deviation divided by the square root of n. When you're doing this on your calculator, I highly suggest that you do the top part first, then hit equals, then hit divided by, and put this part in parentheses, and you can just divide by that whole quantity there. Once you find that T, you're going to check over here, see if it falls on there. Part D, you're just going to tell whether to reject or fail to reject the HO. Number 8. Number 8, the first thing you got to do is finish the chart. So on part A there, you're going to finish the chart. All you're doing is taking the before and the after and subtracting them. So in the D line, you got 110 minus 99. In the D line, the first one there is just going to be 11. The second one, you got 114 minus 125, that's going to be a negative 11. So you got to remember you're subtracting before and after. So the first one's a positive, second one's a negative. The D squared, you're just going to take each one of those and square. 11 squared is 121. Negative 11 squared is also positive 121. Don't forget, when you get down here at the end, you're going to add up this whole row, write that answer in that last box out there, and where it says summation D, and you're going to add up this whole row and write that answer in that box where it says summation of D squared. Part B says state the HO and the HA, and that's probably the hardest thing on this one. The medical researcher wants to test the effects of a calcium supplement on men's blood pressure. In part of the study, 10 randomly selected men are given a calcium supplement for 12 weeks. The researcher measures the men's blood pressures in millimeters before and after the 12-week study, and records are shown below. At a 1%, at alpha equal to 1%, can the researcher claim that the men's blood pressure decreased? So if they decreased, then our thing here should be a positive. Our number should be a positive. Like this first guy's, his decreased. The second guy's, his didn't. His went up. So when we go to write our HO and HA, we want, the claim is that it decreased, so we want our mu D, the difference between the two, to actually be a positive number. So mu D here is going to be greater than 0. That's the claim. And it has to go in the HO or the HA. Then that means the HO would have to be mu D is less than or equal to 0. Part C. Part C, we use the T-chart again because we've got a small sample size. We should have said up here, if we have this, then it's a right tail. So when we go to draw our graph, it's going to be here. Since we got small samples, we need the alpha, which in this case is 0.01, and we need the DF, which is just n minus 1. You're going to take those two numbers and you're going to look up on the T-chart. So again, look up on the T-chart. And it's going, you look up and it's going to give you a positive, and this time you want the positive. Letter D. On letter D, on this one, the first thing you have to do is you have to find your D bar. And D bar is just the sum of the D's divided by N. So in this case, you take this sum right here and you divide it by 10. So whatever that number is, when you add them all up in that in that first row, and you're going to divide by 10 because that's your N. Not 0.10, 10. So once you find D bar, you also need to find SD, the standard deviation. And the formula for SD is this big long formula. It's not really big and long. It's one that we messed up in class the other day. Sum of D squareds, which is going to come from right here, minus the sum of D squared, so this number squared, divided by the number in the sample, which is 10, and all of that divided by N minus 1. So for this spot, you just put in that number. For this spot, you put in that number right there, then you're going to have to square it. The N is going to be 10, so we put 10 in there. Here it's going to be 10, so 10 minus 1 is 9, and it's going to be divided by 9 on the bottom. That's going to find your D and your SD. I'm going to write this over here on the side, because for part D, you also need to find your T value. And your T value is not very difficult once you find D and SD. The formula for your T value is D bar minus mu D, which is going to be 0, over standard deviation divided by the square root of N. Once you find that T value, once you know what it equals, see where it falls out on the chart, and that's going to tell you part E, whether to reject or fail to reject. And then part F is going to be the part where you have to explain it's with a 1% level of significance. There is either enough evidence or not enough evidence, or whatever it says, to support the claim that the supplements lower men's blood pressure. Number 9. On number 9, section 8.4. Again, they give you the numbers here. What you want to do is you want to find, they tell you X1 is 175, N1 is 487. Well, we also need to know P hat 1 to do this. And to find P hat 1, you take 175 divided by 487. And you should end up with something like, let's see, what is it here? 0.36. Then you do the same thing for X2, N2, and again, we got to find P hat 2. X2 this time is 251. And I think you're going to have to do the same thing on problem 10. N2 is 506. And then you take 251 divided by 506, and that's going to give you the percentage there, which is 0.50 or 0.5. For part A, they tell you the claim this time. The claim is that P1 is less than P2. So if P1 is less than P2, that's got to be your HA. That's the claim. And then you should be able to write the HO up here by just changing that sign. Part B, this time we use the Z chart, or the normal chart, the normal distribution chart. Our alpha is 0.05, and I keep forgetting, we look back up here, we have to decide up here, the opposite sign of that would be that sign, so that tells us that it's left-tailed. Well, if it's left-tailed, that means our graph's going to look like this. It's on the left side over here. And that means we just look up that number in the Z chart and figure out what the Z sub 0 is, the critical value that goes with it. You just look that up in the area section of the Z chart. And we write that in right there. We don't have to subtract from 1 or divide by 2 or none of that stuff, because it's just left-tailed. For part C, your formula this time for your standardized test statistic is P hat 1 minus P hat 2 minus P1 minus P2, which is just going to be 0. All that over P bar times Q bar times 1 over N1 plus 1 over N2. So that's the formula to find our Z. Well, before we can find that Z, we know the P hats. We got them up here, but we don't know the P bar or the Q bar. To find P bar, we maybe should have done that at the beginning. To find P bar, you do this: x1 plus x2 divided by N1 plus N2. So your P bar, if we look back at our numbers, is 175 plus 251 divided by 487 plus 506. We do all that on our calculator, we end up with 0.43. To find Q bar, we just take 1 minus that 0.43. So whatever you get there. Then you're going to be able to plug all that in down here in this formula. Once you figure out what that Z score is, you check, see where it falls at on there. In part D, you just decide whether to reject or fail to reject the null. Number 10. Number 10, sort of the same idea as number 9. We need N1, we need X1, we need P hat 1. We need N2, we need X2, and we need P hat 2. They say in a survey of 1,000 U.S. adults in 2008, 570, so we got 1,000 adults, that was our whole sample. 570 is our X1. So to find P hat 1, we just divide those two. 570 divided by 1,000. You end up with 0.57. So that's your P hat 1. Considered the amount of federal income tax that they had to pay to be too high. In 2016, a survey of 1,200 adults, so that's our N2, 500, that's our X2, considered their taxes that they had to pay too high, to be too high. So this is 500 divided by 1,200. You divide that and you end up with 0.42. So that's our P hat 2. Our alpha this time is 0.10. Can you reject the claim that the proportion of U.S. adults who considered the amount of federal income tax they had to pay to be too high was less in 2008 than 2016? So our Part A, we're gonna have our HO and our HA. And we gotta read that again. It says, was less in 2008 than 2016. This is the 08, this is the 16 one. So we're saying, is our P1 less, oops, not. We're saying the claim is that our P1 is less than our P2. That's going to be our claim. And that would mean our HO up here would be saying P1 is greater than or equal to P2. Look at this, that's going to tell us that it's left-tailed. So it's a left tail. Part B says find the critical values. Well, we're going to use the Z-chart this time. So we need to know alpha, which was 0.10. And since it's left-tailed again, we just look up that 0.10 in our Z-chart. We don't have to subtract from 1. We don't have to divide by 2 or nothing. We just look up that, and our answer should be a negative critical value when you find your Z sub 0 on that chart, whatever's closest to 0.01. I'm not sure why my letters are wrong there. I just noticed that they are. So the next one actually says Part E. Not sure why it says Part E and not Part C. Find the standardized test statistic. Again, to find this, we got to find P hat first. Or not P hat, P bar first. And you find P bar by doing X1 plus X2 divided by N1 plus N2. And then you find Q bar by doing 1 minus the P bar, whatever you got up here. So you need to know those two. We got our X1s and our X2s, N1s and N2s, all that up there, so you should be able to just plug that into your calculator, find those 2%. Then once you know that, to find your Z value, your standardized test statistic, you're going to use the formula that we used on number 9, which is P hat 1 minus P hat 2 minus, it's going to be minus 0 there because we don't know the P's, over the square root of P bar times Q bar times 1 over N sub 1, which is 1,000, plus 1 over N sub 2, which is 1,200. Plug all that in there. Once you figure out what that Z is, check up here, see where it falls. And for part F, again, my letters are wrong. You decide whether to reject or fail to reject. Part G then is going to be, it's going to say something like, with a 10% level significance, there is enough evidence or not enough evidence to reject or support the claim that less adults in 2008 thought that they paid too much tax compared to the adults in 2016. Hopefully that'll help some.